Find the sum to n terms of an arithmetico-geometric series. So let's start. We are given a series with the first term being 1, followed by -5, then we have +9, -13 plus 17. Now this is an alternating series. Alternating because the sign is changing from positive to negative, then back to positive, and then going into negative. Now this series, this is not an arithmetic series because it does not have any common difference. Also, it's not even a geometric series because there is no fixed common ratio. However, as the name suggests that it's an arithmetico-geometric series, it means that it's composed of an arithmetic progression and a geometric progression. So what we'll do, we're going to rewrite each of the terms. The first term, we can rewrite it as 1 multiplied to 1, added to the next term, that will become 5 multiplied to -1, added to 9 times 1, added to 13 times -1, added to 17 times +1, and this is going to oscillate. Now here, if we consider the terms starting with 1, followed by 5, then 9, 13, 17, clearly these terms are going to form an arithmetic progression. They're clearly an arithmetic progression because they do have a first term which is 1 and a common difference of 4. And we can immediately define its nth term. So that's going to be given by 4n minus 3. Now, if we consider the other terms, 1 from the first term, -1 from the second term, +1 from the third term, -1 from the fourth term, and so on, this is going to be in geometric progression, because it has a fixed common ratio of -1. So here, the first term a is 1, common ratio, that's equals to -1. Now that we have the first term and the common ratio, then we can also define the nth term of the geometric progression. So that's given by an equals to 1, the first term, multiplied to the common ratio, which is -1 raised to the power of n minus 1. In other words, we have -1 raised to the power of n minus 1. This is going to be the nth term of the geometric progression, with terms 1, -1, 1, -1, and so on, an oscillating sequence. Now that we have the nth term of the arithmetic progression and the nth term of the geometric progression, we can combine them to find out the nth term of the arithmetico-geometric series. So it's simply going to be take the nth term of the arithmetic progression and to it multiply the nth term of the geometric progression, -1 raised to the power of n minus 1. Right. So this is going to be the nth term of the arithmetico-geometric series. And we can verify that. We can substitute n value. Let's say we substitute n with 5. Then a5, which is the fifth term, is going to be given by 4 times 5. So that's 20. We have 20 minus 3. Multiplied to -1 raised to the power of 5 minus 1. That's going to give us a 20 minus 3. That's going to be 17. And -1 raised to the power of 4 being an even number, we're going to get +1. So we're getting a +17 value, and that exactly matches with the fifth term of the series. So now that we have the nth term, let's try to find out the sum. So first, what we'll do, we're going to represent the sum of the series as Sn. So we have Sn equals to 1 minus 5 plus 9 minus 13 plus 17, going all the way up to the nth term, which is 4n minus 3 multiplied to -1 raised to the power of n minus 1. Now the question that arises here, what is going to be the sign of the last term? Now here we will make an assumption here, because if there are even number of terms, then the sign of the last term is always going to be negative. For instance, let's consider the first 4 terms. So since 4 means we have an even number of terms, the fourth term, which is the last term, is negative. If we consider 2 terms, then the second term is going to be negative. However, if we consider positive odd number of terms, then the last term is always going to be positive. So that means if we have 3 terms, we can observe here that the third term is positive. Similarly, if we consider 5 terms, 5 being an odd number, the fifth term becomes positive. So we will assume that there are odd number of terms here, which means that this is only an assumption to solve the problem. So we'll consider, since there are odd number of terms, the last term comes out to be positive. Now we'll also have to consider the second last term. Now how do we find out the second last term? That's a very simple task. All we have to do is replace n with n minus 1 into the last term. So wherever we see n here, we're going to replace with n minus 1. So that's going to give us 4n minus 7 multiplied to negative 1 raised to the power of n minus 2. So that's going to be our last term, and this is going to be negative. Now, what we'll do, we'll consider the common ratio of the geometric progression which we considered. So here, the common ratio of the geometric progression came out to be negative 1. So what we'll do, we'll take that negative 1 and multiply each terms of Sn with negative 1. So that means we have negative Sn. So that's going to give us, so positive 1 will become negative 1 when we're going to write it below negative 5. Then negative 1 multiplied to negative 5 makes it positive 5. Positive 9 multiplied to negative 1 makes it negative 9. And negative 13 multiplied to negative 1 makes it positive 13. So this is going to continue. Now, coming to the second last term of Sn, we're going to multiply it with negative 1. However, we'll be a little bit careful when we do the multiplication. We'll keep this negative sign as it is. We have negative sign multiplied to 4n minus 7. So what we are doing here, we're multiplying negative 1 with negative 1 raised to the power of n minus 2. So using the law of algebra, so negative 1 multiplied to negative 1 raised to the power of n minus 2. So what is it? This is simply going to be negative 1 raised to the power of 1 added to n minus 2. So that gives us negative 1 raised to the power of n minus 1. Fine. So that means we have negative 4n minus 7. This gets multiplied to negative 1 raised to the power of n minus 1. Then coming to the last term of Sn, we're going to multiply it negative 1. So we're going to keep this sign intact. We're going to keep it as positive 4n minus 3. But we're going to multiply that negative 1 with negative 1 raised to the power of n minus 1. And that's simply going to give us negative 1 raised to the power of n. Fine. Now what we'll do, we are going to perform a subtraction here. So here on the left hand side, we have Sn minus negative Sn. That is going to be equals to, we're going to keep the first term of Sn as it is, so it is will be remaining as 1. Next we have negative 5 minus negative 1. So that makes it negative 4. Added to, we have 9 minus 5, that makes it positive 4. Then negative 13 minus negative 9 makes it negative 4. Added to positive 4. And this is going to go on until we reach the last term of Sn, from where we will be subtracting the second last term of negative Sn. Now here what we'll do, when we do perform the subtraction, that is going to leave us with positive 4. But we need to multiply it with negative 1 raised to the power of n minus 1. So here we have what we have done here while subtracting, we have taken negative 1 raised to the power of n minus 1 as the common factor. So we have subtracted 4n minus 7 from 4n minus 3. And this is going to give us a positive value 4. Then we have minus the last term of negative Sn. So that's going to be 4n minus 3 multiplied to negative 1 raised to the power of n. Fine. Now Sn minus negative Sn, that's simply 2 times Sn. What we will do here, we're going to keep the first term as it is, and we are also going to keep the last term as it is, which is negative 4n minus 3 multiplied to negative 1 raised to the power of n. What we will do, we're going to combine the second term all the way up to the second last term, because this is a geometric series where the first term a, that's equals to negative 4. The common ratio r, that will be negative 1. And we have a standard formula for finding out the sum to n terms, that's given by a multiplied to 1 minus the common ratio r raised to the power of the total number of terms, that will be n, divided by 1 minus the common ratio. So we have the value for a, the first term, which is negative 4. We have the common ratio negative 1. Now we need to find out the total number of terms that's present here. Now here it's going to have n minus 1 number of terms. It's not going to have n number of terms. Let's try to understand why this is happening. Now consider Sn. So here if we exclude 1, because total Sn has a total of n number of terms, so if we exclude 1 starting from negative 5, which is the second term, and going all the way up to the last term, here we are going to have n minus 1 number of terms. For the next sum, negative Sn, we start from the first term and go all the way up to the last term. Here we are going to exclude the last term. So here also we have n minus 1 terms, because in total we have n terms. If we don't consider, if we exclude the last term, we will be left with n minus 1 term. So we have n minus 1 terms from Sn, and from here we are subtracting n minus 1 terms from negative Sn. So that's going to leave us with n minus 1 terms. So that means in total there are n minus 1 terms for the geometric series. Now let's apply the general formula. So here we have So this is going to get added to. Now the sum will be the first term, which is -4, multiplied to 1 minus the common ratio. The common ratio is -1, and we're going to raise it to the total number of terms, so that's n minus 1. This will be divided by 1 minus the common ratio, which is -1. Now let's further simplify. We have 2 times Sn, that will be equals to 1. Now we have -4 divided by 2, so that makes it -2. This will get multiplied to 1 minus -1 raised to the power of n minus 1. Minus, we have 4n minus 3 multiplied to -1 raised to the power of n. Fine. Let's do one thing. Let's simplify furthermore. We have 1 minus the 2 times 1. That's going to be 2. -2 times negative, this will become positive. So we have 2 times -1 raised to the power of n minus 1. Minus, we have 4n minus 3 multiplied to -1 raised to the power of n. Fine. Now, we have 2 times Sn, that's equals to 1 minus -2. So that is going to give us -1. Then we have 2 times -1. So let's do one thing. Let's take -1 raised to the power of n minus 1 as the common factor from this term and this term. So now we will have, let's remove this 2. We have -1 raised to the power of n minus 1. So that means this is going to get multiplied with, so we'll be left with 2 minus, so here we'll be left with 4n minus 3. But we have taken -1 raised to the power of n minus 1 common. So that means from -1 raised to the power of n, if we take -1 raised to the power of n minus 1 as the common factor, so that means we are going to have -1 raised to the power of positive 1. Fine. So we have 2 times Sn, that's equals to -1 added to -1 raised to the power of n minus 1. We have 2. So -4n minus 3 multiplied to simply -1 makes it positive. So we have positive 4n minus 3. We get 2 times Sn equals to -1 added to -1 raised to the power of n minus 1 multiplied to 4n minus 1. Fine. Now we will finally divide throughout with 2 such that Sn becomes equals to -1/2 added to -1 raised to the power of n minus 1 multiplied to 1/2 multiplied to 4n minus 1. So this is going to be the final value of the arithmetico-geometric series.